Hello, calculus fans. Okay, so we're going to try to compute the derivative of the inverse tangent function now. We're going to follow the same procedure that we did before, using implicit differentiation based on our cancellation formulas. So if we let y be equal to the inverse tangent of x, then our cancellation formula tells us that tangent of y is equal to x. Our goal is to find y prime, so we're going to use implicit differentiation as applied to this equation here, the tangent y equals x. So if we differentiate the left-hand side, we're going to get secant squared y times y prime. So that's because the derivative of tangent is secant squared, and then we have to use the chain rule to get the y prime with that as well. And then, of course, the right-hand side is just going to equal 1. So if we solve for y prime, then we end up with this equation here. Y prime is equal to 1 over secant squared y. And of course, it's a little tempting to rewrite that as cosine squared, but I actually want to keep it like this, and we'll see why in a moment. Now remember that we have an alternative form of the Pythagorean identity, and that looks like tangent squared y plus 1 equals secant squared y. You have to remember how we got that. We started with the ordinary Pythagorean identity and divided both sides by cosine squared, and that's how we got this. So if we go back now to the expression that we've come up with for y prime, this equation here, then we can substitute secant squared y for tangent squared y. So we have y prime equals 1 over secant squared y, which then gets turned into 1 over tangent squared y plus 1. Now the reason this is useful is because how is x defined? X is tangent of y. And so now down in this expression that we've come up with, we can replace tangent y with x. And lo and behold, that gives us a formula for the derivative of y. So that's the thing we're looking for. We've got a formula now that says that the derivative of the inverse tangent of x is equal to 1 over 1 plus x squared. Just as an aside, I'd like to point out that it's probably useful to know the limits of arctangent going both to positive and negative infinity. The limit as x goes to negative infinity of arctangent is negative pi over 2, and if you go off to positive infinity, then you're going to get positive pi over 2. Okay, that's all for now.